fait très plaisir. On aurait dû prendre une salle un peu plus grande, hein, puisque vous êtes quand même assez nombreux. On en fera une plus grande la prochaine fois. Alors, juste avant de commencer la première conférence avec Yves, qui est un expert justement du trading algorithmique, qui fait des conférences à Paris, à Berlin, à New York aussi. Il la fera aussi en anglais. On vous a mis un petit questionnaire normalement, donc sur chaque chaise. Nous, ça nous permettra en fait chez FXM de comprendre un peu les besoins des traders algorithmiques, parce que c'est un petit peu le nouveau segment qu'on veut développer, c'est vers ce type de trader-là qu'on souhaite s'adresser, donc n'hésitez pas à le remplir. Et si vous avez des questions, n'hésitez pas aussi à venir nous rencontrer après la conférence, on est là pour ça, il y a toute l'équipe. Et voilà, j'espère que ça vous plaira.
Thank you. Yeah, welcome everybody. And sorry, first of all, that my French is not good enough to give a talk in French. So I used to have French for like 6 years at school, but no practice, no context. This is not the best kind of environment to learn a language, so I regret that. But I hope that kind of the talk will be, since it's about algorithmic trading, and trading is kind of an international affair, a global affair, will be kind of what you expect. And I think the details should be clear because they're partly they're formal on that level. But let's get started simply with the topics there. Yeah, my talk is entitled AI First Finance. I'm using AI First since quite a while because I think we are now in 2018 seeing a paradigm shift, and I got good support for this 2 weeks ago in New York at the conference, which was exclusively about machine learning and AI in quantitative finance. Partly about algorithmic trading, but many people have been reporting there about advances in the field and how AI and machine learning are changing the field. And I think algorithmic trading is one of the subfields there which is influenced most by what is going on in the AI field. I will start with a quick introduction. It's really brief for what we do. If you're interested in what we do at the Python Quants, the company that I founded, you find the most important things are further links on tpq.io. I think pretty easy to remember. The slides are online anyways. I will point you to the sources in a minute. All what we do is mostly centered around Python for finance, and algorithmic trading has become more and more important over the years. So we work not only with big financial institutions around the world, we work with many retail traders, with programmers, data scientists that want to get into the field, they want to learn Python for algorithmic trading, or the other way around. They know maybe a little bit about Python, programming, or maybe even experts in the field, and they want to get into the algo trading space. I've written a few books, I will show them in a second. We are running a quant platform, more than 10,000 users, I think some 12,500 these days. We run events, you've heard this before, in New York, in London, recently also in Frankfurt, once again after a while, Berlin, and I'm traveling the world regularly, although I'm German, located in Germany. Less than 10% of what we do is taking place in Germany. With regard to all my talks, you find the resources under hilpisch.com, so this is not about myself personally, rather about all the talks that I give. Typically you find resources there in the form of Jupyter Notebooks, of GIS, of GitHub repos, and so forth. So if you're interested in the field Python for algo trading, I think you find, or other finance subfields, you find quite a few resources there. These are my 3 books on the topic. I'm currently in the course of writing the 2nd edition of Python for Finance, which is the most popular one. This is used around the world, I know, from many people, from feedback, emails, not only by professionals, hedge funds and banks, it's also used these days at universities and more also in the business field, which I noticed recently that more and more people are doing MBAs, for example, are these days confronted with some programming classes that they need to do. And of course, the language of choice more and more is Python these days. Let me get started with the topic themselves, data-driven finance, which is one part of the story. And we all know this, of course. I still enjoy having kind of newspapers in hand and reading through it, especially when I'm sitting on the airplanes. I don't have any subscription anymore to a daily newspaper because basically we don't need it anymore. And I'm pretty sure that fewer and fewer decisions are made based on what you read in the newspapers. It's too slow, it's too hard to process, and you can't simply compete with what machines can do. So the first step in the evolution was that we had these terminals here, the HTML5 version, the web version of Icon, and of course when I'm interested in something about an Apple stock, for example, or the Apple stock, I don't go to the newspapers and look something up. I simply log in here and I get all the overviews to see here, year-to-date performance and all these things, fundamentals, news, and everything related to a single stock. So this is, of course, the standard in the industry since years, but we have now entered the next stage where even this is not enough anymore. We need to have programmatic access to data, because this is much faster and we simply can't compete sitting in front of our screens or sitting on the airplane having the newspaper in our hands. We cannot compete against the machines, because the machine, they can read data with speed and with breadth and depth that we simply can't manage as human beings. You see here one screenshot. This is taken from last year. This is kind of a live example. It's a quarter of an hour for the Apple stock, and you see that I retrieved here close to 2,000 ticks for a quarter of an hour. Nobody would ever like to print this. Nobody would ever like to read even through something like this. Maybe just to have a look here at the first couple of observations, that is fine. But this is what the machines are up for, and much more than this. They can do this for, let's say, 100 names at the same time. They can do this on order book level and so forth. But not only that, then some people say, well, but I love to read the news, I want to be informed, but the machines read the news as well. So here, the other example from Thomson Reuters, again, a company we're working with, and we're doing also training based on a new Icon data API for them. See, I can simply search for news, I read the news, and then not only that, I can have an overview here, the machine can parse it, so I can say, well, give me the complete text, and then I use natural language processing to get through the text, and the machine can read maybe in, let's say, in a few seconds, thousands of articles, where I would need, I don't know how many hours to get through all that stuff, and afterwards, when I didn't figure out something, I'm even disappointed. So this is how far we have come to. And the major basis for my demo today is, of course, the new FXCM API, which has release date this week. So I want now, after this, show how easy it is to retrieve data from FXCM. Anyways, so if the internet connection works, I should be able to retrieve data here in my Jupyter notebook. But maybe I ask a question: who is using Python? Most, maybe like half. Who's using it for finance and algo trading or whatever subfield? Not too many. This is kind of a smaller subset, obviously. But I think if you have a Python background, what I'm going to show should be kind of more or less self-explanatory. I think this is one of the major advantages of our language, the Python language, that it's usually easy to read, even if you're not an expert in the field. And with the high-level APIs, it's even easier, like using pandas and so forth. So risk disclaimer, of course, all the stuff that I'm going to show is about Forex and CFDs. I can only recommend that you read carefully through the risk disclaimer before you do anything in this regard. The speaker disclaimer: I'm neither an employee, nor an agent, nor a representative of FXCM. All that I'm going to show is based on the REST API in the Python wrapper that we have written, but it's not, so to say, endorsed by FXCM. Reading tick data. I mean, I've shown the example of Apple in 2000 for a quarter of an hour, but the same holds true, of course, in FX. So here, let me get started. This might take a few seconds. You see, I'm importing the FXCM tick reader. Tick data from FXCM is available for a bunch of currency pairs. And when I start retrieving the tick data, you will notice that this takes a while. This is due to the fact that currently FXCM provides data in weekly chunks. So they are provided on a server. And since these are weekly chunks, we retrieve a little bit more. So although I've specified start and end date to be 7th and 8th of March here, I will retrieve the complete data set for the week. So when you see 10.csv here, this is the 10th week. This is a special type object here, and you see that I've retrieved 1.4 million tick data points just for this 1 week for which I requested the data. Having a look at it, you see that we get bit ask, and of course the timestamps for which we got the data. So well beyond, so to say, the newspaper, well beyond the terminals where you never want to read through 1.4 million data points. This is not what you want to do. Here with pandas on my little notebook with a decent internet connection, you can process the data. And what is happening now in the back end is that the data is transformed. And once it is transformed, you see it doesn't take 6 seconds, it takes 13 milliseconds afterwards. But let me pick out kind of a smaller subset of the data here, just like a tenth of it, so 144,000 instead of 1.4 million. And using Plotly and cufflinks, I can get this plotted here. So for the first plot, it takes a while. So you see this is the data, or parts, smaller part of the data that I have retrieved. Of course, nobody wants to read through 144,000 ticks, but visualization is still something that we are good at reading as human beings. So the next point in terms of data-driven finance is now the REST API, because the first example wasn't about the REST API, this was about tick data, which is beyond the REST API. Here, the connection takes a little while. Typically, what I'm going to do is now I'm connecting to the REST API. In order to do this right now, what I'm doing, you need to have at least a demo account, which are available for free. And FXCMPy is also available for installation via simple pip. You see it up here. Pip install FXCMPy, and then you have access to a bunch of instruments. Not only the currency pairs that we have seen before, but also to other CFD instruments that FXCM provides on the platform for trading. And for all these instruments that you see there, we can retrieve historical data. I will focus the rest on FX data. So here I retrieve candles for US dollar Japanese yen, period 1 day, just 10 candles. Candles, therefore, because we get for bid and ask, we get open, high, low, close columns, as you can see here. Just 10 days, of course, this is a tiny data set, maybe for inspection. You can, of course, provide start and end dates as well. So here I'm retrieving data now for the last year, daily data, and I can take this daily data and plot it once again. Here using Plotly is kind of nice. I have interactive visualization, so I can zoom in, for example, zoom out, and have a little bit more analysis capabilities than with standard Matplotlib. Now I'm retrieving 150 candles, but 1 minute bars. Here see I've changed the period, so 1 minute bars is what I'm retrieving here. And I just want to show, although we are talking about algorithmic trading, of course we human beings, we want to inspect the data that we work with before we let the machine crunch and work on it. So using Plotly and cufflinks allows us to do some nice financial visualization as well. So here you see a classical candlestick plot. I can zoom in and analyze the candles there. So this is nicely implemented, actually by a friend of mine in London, by Jorge Santos, which has written this fantastic wrapper for Plotly, which combines pandas with Plotly as an interactive visualization library. And just to show one example, Bollinger Bands, many indicators are implemented, like RSI, SMA, and whatnot. I don't know how many, maybe 20, 25 are implemented at least, that you can use here for visualization. Again, we are here in the algorithmic trading part, but at least if you say, well, I want to do some technical analysis, I want to do some visualization, I want to zoom in and have a look first, this all works. You can drill down as far as you like. In particular helpful, I think, when you work with tick data or, let's say, high granularity, like 2nd or 5-second bars, for example. So this just to show that we've come a long way. So data-driven finance is reality. Is not only reality for the biggest hedge funds in the world, for the biggest banks in the world, it's reality even for retail traders that are interested in trading such instruments offered by FXCM, like Forex or other instruments. You have access, you have full access via the Python wrapper that I've shown now partly. I will show a little bit more. And you have basically access to all the data that is there. So not all the data in the world, but all the data related to the instruments in different granularities. AI first finance. Now the next step. Data drives it, but artificial intelligence is driving it, I think, even more so now that we have the data available, because now big data comes into play. Most of the algorithms in the AI field, they have a need for huge data sets. I mean, this is after the big data wave, then AI is now kind of the hot topic, but this all builds on big data, because once again, many algorithms do not work simply with small data set or even mid data sets. Therefore, the availability of tick data and long time series data and kind of the breadth of data sets is kind of prerequisite for the fruitful application of AI. I want to get started here with a little excerpt from an Economist article, and I think although this is related to physics, we could translate this to the finance field. The beauty myth is kind of something that is here related to the grand unified theories in physics, where they say, well, some of them are really nice and the brightest minds in the physics world are working on it, but to some extent they don't have really some explanatory power. They might be nice, but here you see numerological coincidences are what the researcher here says characterizes them. So they might be nice, but not really of use. And in finance, we have suffered from similar aspects, in the sense that many of the theories, many of the stuff that has been written, published in textbooks and research papers, looks nice on paper, but it doesn't work out pretty well in practice. So this is kind of a real issue. But now, these days, we see it already. Here's a little bit of an older quote. So in the AI area 3 years ago, it's kind of a little bit old already. But it's a book from 2015. It's not explicitly about finance. But the author states here that, of course, algorithmic trading programs, they make already use of AI, but more or less in a simplistic fashion. And if there is something in it, in terms of that artificial intelligence might be able to spot patterns, and if the patterns have any use, then for sure the machines are better at discovering patterns and acting based on patterns. So this is what is said here. And what does it mean? I mean, we all know this. This is just one picture I found on the web. There are thousands of such pictures showing, here in this case, 20 different patterns. Like the first 5 saying, well, if you see something like this, you can assume that the market, whatever the market is, whatever instrument you're looking at, might go up. And the next, I said 5, I think, no, 8, the first 8 here, they might signal that the market goes down. And then you have others where you see some reversals. But once again, I mean, if there is something in it, in these patterns, I don't say yes or no. At this point, this is not my argument. But if there is something in it, machines are for sure better at discovering if there is something in it and in acting and what is happening there than we human beings can ever be. Maybe we can remember and can spot these 20, but the machine doesn't have a problem with dealing with 20,000 patterns and analyzing them to the very last detail that is available. And in that sense, when we compare what is going on in the AI machine learning world with what our requirements are, many things go in parallel. And we have kind of, for the first time at least, I mean, I've been studying finance for well more than 20 years, for the first time we get more impulses out of our field or from the outside of our field than from the inside. Because that many things that we are now applying to our field, machine learning, deep learning, TensorFlow from Google and so forth, which is used for self-driving cars, for instance, can now be applied these days to come up with trading strategies. And the problems and the solutions are similar. So we deal with data, we need algorithms, we need hardware to run all this. We do optimization, we train the models, we learn something about if we have learning algorithms, which means we iterate over all these things, we test it, we validate it, and if Google or the Teslas in the world are after self-driving car, in our field most people are after AI-based algo trading machines. And we have 2 elements which make the work in our field a little bit easier. The one thing is that we don't have the embodiment problem. So after all, if the AI is there, you still need to build the car which is driving around. So we don't need the machine which sits there and trades. So it's just software, actually, which we take care of. And the second point is that typically in our field, it's not a question about life and death. So many discussions that you hear around self-driving cars and so forth about safety and what happens if an accident is there, who needs to appear in court. The car cannot appear as the owner or the guys who built it. So I think we have it a little bit easier, but nevertheless we have different problems. In particular, when it gets to data and the algorithms themselves, there need to be certain adjustments. We don't have physical laws in our field, like once the machine has learned when to drive left and right, this might be okay. For the foreseeable future, there might be extreme cases where the machine might not be kind of perfectly trained, but in the financial field, it's different. So we don't have physical laws We don't have stuff that is kind of stable for 30 years or whatnot. So the requirements and the data and let's say the green field where we start from is a little bit different. But who has seen this book already? Nobody? I brought it with me from 2 weeks from New York. It's brand new. Actually, Marcos gave a keynote there, mostly focusing on the first chapter of the book. It's, I guess, to my knowledge, and he writes it as well. Currently in the middle of the book, he writes as well that, to his knowledge, the first book which really covers financial machine learning. So this is also kind of an indicator now that books are coming out, and not only some smaller research papers, that quite a bit is going on. And there are a couple of nice quotes, so I've tried to more like the ones that take reference to what is going on currently. But they say, well, the essential tool of econometrics is multivariate linear regression, an 18th century technology that was already mastered by Gauss before. Oh, this is of course wrong. It's not 1974, it's 1794. So this kind of change in color. So in the 18th century, so to say. And it's hard to believe that something as complex as 21st century finance could be grasped by something as simple as inverting a covariance matrix. Also here, on the other hand, an ML algorithm can spot patterns in a 100-dimensional world as easily as in our familiar 3-dimensional one. So driving a car means, yeah, of course, many features, but a 3-dimensional world. But financial markets have many, many dimensions, and it can get really complex. And econometrics might be good enough, he writes here, of course, a little bit on the vocational side, succeed in financial academia for now, but succeeding in practice requires an now. So he's saying, well, we are now at the threshold where regular econometric methods are not enough anymore to make some money. You might be able to publish a paper, but not to make money anymore in this regard. AI first finance, from my point of view, therefore replaces the history, the finance history, or is at least about to do so. This is more like a forecast, more like a hypothesis, in that sense where we have, of course, the nonlinear, complex and changing market environment. The financial markets process ever-increasing data sets. So the data sets are getting bigger and bigger, and history was driven by brains coming up with kind of like nicely formulated equations, like single liners, beautiful but often of no use. And this is what I want to reference here, the beauty myth that I mentioned before. AI first finance now gets it in the right sequence, like in science. You start with the data, you have a bunch of models that you can parameterize, which select from, so nobody says which one might be the best for everything. No, you need to do model selection. You have many parameters that are free. You can decide upon your features that you use and so forth. And even if something complex is the result, like a deep learning network with multiple hidden layers and so forth, and you cannot fully explain it, it's not as beautiful. If there is some value in it, and if it works kind of better than the beautiful equations, of course. I mean, for me, it's clear what I would use, even if I have studied this for years, among others, for my PhD. I would, of course, like to use what is working and not what looks beautiful. Now, getting back to FX, actually, it's a little bit surprising because I've been working mostly on the equity side, and in equity trading, it's well more than 50%. It depends on the days, of course, and what's going on. Some people speak of 75% already is driven by systematic trading, by algos that execute trades. And in FX, it's not yet there. So this is an article just from the 8th of February, so roughly a month ago, where it's pointed out that roughly just 1 in 10 traders in the FX markets are using algos based on AI, and this is of course increasing. The bigger ones, the mid-sized ones that are kind of the front runners here, but more and more people can give it a try. And once again, getting back to the retail trading story, it's even possible for the retail traders to make use of algos, of AI-based algos here as well. Therefore, I want to now get back to the demo. What we have covered already here in this regard is the first 2 layers. So the pyramid is something I use for our trainings intensively, so kind of structuring what we teach people who want to get started in Python for algo trading. And I've shown already a little bit of the infrastructure. It's not that much about infrastructure. I'm using Python and Jupyter. I've shown tick data, historical data, via the REST API. Real-time data, not yet. This comes in a few minutes. And now I'm going through the rest of the layers there, like the strategy code using an SVM classifier, support vector machine. I do some vectorized backtesting to see whether there's something in such a classifier, whether strategy performs well or better than the benchmark. I show how streaming works, or how easy it works actually. And order placement, of course, is also something that you need to accomplish. If you have the best signals but are not able to trade, where is the point then? So order execution, and the hardest part is the automation. And therefore, I'm just showing a pretty simple algorithm there. But let me change to the demo back here. I have read already data before, but now I'm going to work with a little bit of a larger data set. So the data set now has 577 data points. You see it here, it's 5-minute bars. So before I had daily bars, I had 1-minute bars. Now I'm working with 5-minute bars. These are just a few of the ones that you have available. And if you are after some other granularity, you say, well, I'm the guy who's trading 3-minute bars, then you can use the tick data and can resample it to 3-minute bars if this is what you're after. So the tail end here, I'm just working with mid-close, and the data set itself is kind of a nice kink. Actually, I only updated this today. The last 2 or 3 talks I have given based on data from February, so I just moved it to 7th and 9th. Before it was 7th and 9th of February, now it's 7th and 9th of March, and I stuck to it because the results are pretty nice. But before, you might have read the red text there. It's of course no investment advice. This is just a technical example, and before you start trading something like this, you should go absolutely into details and should be completely aware of the risk. But this is kind of a nice data set. Where we have a larger drop here, at least in relative terms, because for the machine, once we get started and train the machine on this, this is the world of the machine. The machine, in this case, doesn't know more than what we see there. So, and it's kind of nice to have this kind of larger drop in relative terms. Once again, you would say, oh, well, this is kind of a typical movement, blah, blah, with the regular range, blah, blah, blah. But this is not the argument. The argument is if a machine only knows, for example, the first part. So if we zoom in and train the machine on something like this, the machine would later on come out obviously with something else than if we have something like this in there. But I will also train the machine in a randomized fashion. But first, let's start out simple and train and test it very simply on this data set from last week. First thing is that I'm calculating some log returns here. This is all pure Python. I'm creating just 3 regular feature columns based on the returns and 1 momentum column. I said, well, the average of the last 5 returns is what defines my momentum. So very simple definition. When I do the plot, this plot is just to illustrate what I'm going to do is not somehow to work with the mid-close price there. This is nothing I'm interested in. I'm also not really interested in forecasting the returns themselves. What I'm interested in is based on my classifier that I'm going to use just to predict the market direction. So I'm not interested whether I might be interested, but here in this example, I'm not interested in whether the market might make a huge move and how much capital to deploy. These are all valid questions, but here it's a very simple example where we're just interested in market goes up or market goes down, market goes up or market goes down. And this problem can be easily cast into a classical machine learning setup where we have a couple of features, and you see here there are just a few making up for just 16 different patterns. So it's very simple here. Of course, we have seen before in the code, maybe we might have 100 patterns with respectively many combinations there. But here, just 16 of these patterns, like 1111 or 0000 or 1010. I think you see the point here. Now the application of the support vector machines approach. It's kind of simple with scikit-learn. I define my model, and this is now the data set I'm working with after all the crunching. So 571 rows, and I do the fitting there. With such a small data set, it's pretty fast, but SVM models are known to not scale well the larger the data set. So here it's pretty fast, but the larger the data sets, the higher the computational burden, so to say. And here I'm doing the prediction, and the prediction actually gives me -1, +1, -1, +1, whatever kind of the pattern is. So simply saying -1 the market goes down, or +1 the market goes up. And for every single data row that I have created, I get such a prediction. When I now do the backtesting based on the returns, you see in sample, here are the comments. This is unleveraged, no bid-ask spread or any transaction costs, and it's only in sample. So many people doing machine learning will say, well, it is well to simplify, but this is what I said from the outset. This is the starting example, pretty simple, and you see the machine learns kind of well, when the market might go up and down. In sample, it has kind of a nice outperformance, while the market here, in our case, euro US dollar, is losing some 1% over the period. The strategy earns some 1.5%, so it outperforms it by roughly 2.5%. Would be nice if this would work out always. If you now include some leverage, you might see already the millions flowing there. But it's not that simple. Therefore, to make it a little bit more realistic, what I now introduce is a randomized train test split, so that we not say, well, we have in sample. What I could do now, and what many people do in the finance area, is kind of that they start, for example, with the first half, they train it on the first half, and then they test it on the second half. As one example, or they make rolling windows with the same kind of idea. But getting back to the data that I've shown before, up here, you see if I train it just on the first half, what do you think how successful the algorithm can be in learning about such a drop here? Probably not, because if I train it on the first half, nothing like this ever happens in the first half. So this is what many people have noticed over the last years when they got started with something like this, that they said, well, I've trained it on this, but what happens afterward, or what happened afterward, was never seen by the algorithm. How could the algorithm ever come up then with a solution for that, or with the right prediction, so to say? Therefore, what I'm doing is I do a randomized train test split. It's typically also the harder thing to do, because you'll not end up with kind of homogeneous time intervals. And I also doing here some more granular clustering, so to say. Before I just had kind of the 16 combinations with what I'm doing here. You see I have now not only the zeros and ones, or minus ones and plus ones, I have zeros, ones, twos, so there might be some threes, so I have a total of 4 categories. Keeping the number of features the same, I have already 256 patterns. 16 for human beings, still maybe to spot. 256 already, I think, is beyond the threshold. And to visualize the randomized train test split, you see here kind of the blue ones are the data points that I use to train the model. The red ones are the ones to test it. So I really use an approach where we randomly pick out 50% of the data set for training and 50% of the data set for testing, and not beginning and end or some other mechanism is randomized. And you see this leads to the point that we train it, for example, as well on the later stages, and we test it then throughout the complete time interval. So hoping that we like hit all that we might be faced with. So same holds true if it would work with, let's say, 2 years worth of data. 2016, 2017, you train it in 2016, you test it on 2017. This might be excellent, this might be bad, but taking the whole thing and clustering might be the better one. Here, just to have a more detailed look towards the end, these are just the last 100 points. Model fitting and testing is now kind of just a few lines of code. Same as before, it's just a couple of milliseconds for this small data set. The accuracy in sample that I'm calculating here, I didn't show this before, is 73%. I would like to have out of sample 73%. This would be the nice thing. But out of sample, we just get 55%. So usually what you see, and this is then when people speak of overfitting, that in sample you have something like 90%. In particular when you use deep neural networks, which are really flexible, you get high in sample accuracy, but usually on this at the same time you get a lower out of sample accuracy for what you see. I think here it's kind of, it looks kind of okay. What I would like to have is the two of them rather close together and as high as possible. So I don't want to have this spread, so I want to have them rather close together and the two of them as high as it can get. But here's a very simplistic example, once again, just 4 features. So you shouldn't expect too much. Now I'm doing the backtesting so that we have a look. This is the in sample. And we now must consider, although I've sorted all the points now together in the right sequence and I've put them together, this is not a homogeneous time interval. You remember the blue dots and the red dots? These are now the blue dots taken together, and I'm testing the in-sample performance. Looks kind of nice, even better than what we've seen before. The benchmark performance is roughly the same because we have picked out the single points randomly. But the more important part is the out of sample, and this works here kind of well. I said before, when I've moved this by 1 month, I ended up with these nice results. And here, once again, I must say that this is hardly ever the case, in particular with such a simple model and just 3-4 features, that you get such an outperformance, which is here not spectacular, because you need, of course, to take into account the scaling here on the left-hand side. But still, it is kind of seems to be like a systematic outperformance. The point rather here is that we have access to data. Finance is data-driven these days, and the application of all the nice methods that people are using in other fields is kind of straightforward and simple. It's just a couple of lines of code, and I'm getting started. I'm not saying that I'm already at the end here, and tomorrow I will deploy this algorithm for trading. This is what I'm saying, but everybody has access. It's open source, it's easy to use, and just a couple of lines of code to get this up and running. What is also not included here, you see it here always in the comments, is out of sample. Yeah, this is kind of the hard parts, unleveraged, this is neutral, but no bid-ask spread or transaction costs. Of course, even if we see any kind of outperformance, we need to take into account how many trades we see there. So number of trades here is 265, so every second bar there's a trade taking place. So my prediction would be that the trades alone and the bid-ask spread would eat up the outperformance that we see there. So now we have arrived at the point where we have maybe a strategy and say, well, now we want to get started with trading. And get started with trading means that we need to be able to digest data in real time. So we don't want to sit in front of kind of like and see what is happening and looking what. No, the machine needs to be able to retrieve data for euro, US dollar in our case in real time. And you see how easy it is. I subscribe to market data. I pass in the callback function, and this is a rather simplistic callback function. The callback function does nothing else than to print out the retrieved data. Of course, you can collect it, you can work with the data, you can then run your algorithms on top of the data, and you can place orders, for example. You have always full access to the data in real time, and in the back end, it is also collected in a data set. So it is as simple as that. It's based on socket communication, it's in real time, and you subscribe to it. And what is to be done with it, this is a completely different question. But the functionality is there to programmatically access the data that is created in the markets in real time. And then you say, well, now I'm up to speed. Who's texting me here? Sorry. I'm up to speed with kind of like the strategy is clear. I get the data, I access it, I use it, but now I need to be able to place orders. And to this end, let me quickly check whether it's still open. Here it's not kind of large. This is the trade station, the application of trading application of FXCM, and I can, via the API, check my open positions. There is no open position. I have not placed an order. Let me quickly check. So now you see, to decrease it a little bit. Now you see that there is one open position. It's one lot, so 100,000 euro US dollar. are now in my account, long position, and I can of course read out the open positions here as well, so via the API. Now creating another order. This all depends also a little bit now on the Wi-Fi here, the guest Wi-Fi, and you see that we now have 2 open positions. I see this in the trading station as well. Second position is showing up down here. And so forth, and so forth. I can now create a sell order, reduce my euro-US dollar position. I can create another market buy order. All the way down, I can check what the positions are, what kind of the size of the position is, what the cross P&L is up to that point, and so forth. So I have full access to it. I'm just showing here market buy and sell orders. Of course, you have access via the REST API to all types of orders, entry orders, trading stop orders, OCO orders, so all types of orders are available via the API. So then here is the last point where I've, for the last time, adjusted my euro-US dollar position. But I can, for example, say, now I'm closing out US dollar Japanese yen, and I see that the 2 positions have vanished at once. And when I execute close all, you don't even need to know any Python at all. Close all says it all, hopefully. And you then get open positions to see that we are clear. And in real time, you also see here no open positions left in my account. Of course, you don't need to check all the time, but this is what I use to demo that when I do something in Python, it in real time shows up, of course, in the trading station for my account. The last little thing here that I'm going to demo is an algorithm, an automated trading algorithm that does nothing else than going long euro-US dollar, 100K, one lot, and selling the position out after 7 seconds. So this is maybe not the most intelligent, not even artificially intelligent algorithm, but it is an algorithm that does automated trading. And it's just a couple of lines of code. I used to have a more complex example, but I think the major point is about the automation part, that when I have something like this, hopefully with more intelligence, with more profit potential, then it's kind of straightforward, of course, to automate that as well. I will comment on the automation part, although I'm running out of time a little bit, right afterwards. It is already the last code snippet that I wanted to show you. So this is still running, and after, because this is just a fixed loop, after 5 iterations, when we see trade 4, this whole thing will then be closed out automatically. Again, time-based, but automated. In that sense, we have now covered all the 7 layers that we typically cover during our programs, and what our program covers is quite a bit. So this is our flagship offering, is a certificate in Python for algo trading, which we award in cooperation with with our local university in Germany. And I see it's 150 plus hours, 60 weeks, it's 1,200 pages, thousands of lines of code. So I think you learn quite a few tools during the program, of course, an integral part will from now on also be the FXCM REST API, since it is now released, or this week will be released and officially available. There's also already, just to point you to that, the documentation available. And during the documentation you see that if you're already in the Python game, so to say, you should be up and running within minutes. So there is not that much to do. You pip install FXCMPy, you open a demo account, which is an easy and quick affair, and then you are up and running technologically. You can then use what is there, just to give you a glimpse of what to expect in this regard. But, and this is now the second but final part, which I want to spend 2 minutes. We have noticed that although we have trained people now since a couple of years, based on all the materials that we have developed and that we have further enhanced, it's actually pretty hard for people to get their algos deployed, and that's the reason why we are working on what we call the machine, and the first versions are available. I just today uploaded 2 demo videos on our YouTube channel. about the machine, so which takes care of the deployment around the AI. Because we have noticed that many people really master Python so far that they come up with strategies and have some ideas, and once it gets to the deployment part and you want to have your strategy run for like a week or 4 weeks consistently, you want to have some audit capabilities, it's pretty hard to do. So we, from our point of view, close the gap in terms of deployment. Because the brokers and the platforms like FXCM are doing a great job. They provide the infrastructure, they have the APIs available, they provide the wrappers, they do education, they do meetups like this here. And the people they train, they get practice and they do research, but nevertheless, once you want to get started, for like weeks on end, this is a hard thing. This is a really hard issue to solve, and you can speak to people from the bigger asset managers or hedge funds. This is actually where most of the time is spent, actually, to have this available. So basic idea is you are the experts who do the research. You come up with your idea. Then you can backtest your model on our platform, on machine, connected, for example, to FXCM. In this regard, you have all the backtesting results, and there comes the point where you say, well, now this is kind of a fantastic thing I've come up with. I want to go live with it. And it should be as easy as that. And I say, well, this is my model, this is plugged in to the infrastructure, and now I just say what quantity to trade, maybe some other risk measures like stop loss, for example, and then you have full audit capabilities. You see here in real time where long and short positions are open, what the signals were. So whenever you see something green, this means it was a right signal. If it's red, it was a wrong signal. You get full exposure to all the data surrounding such trading strategies. And this, once again, is supposed to be in the live area, not in a backtesting one, where we are used to analyze every single data point, can dive into it. But this is now on the trading side, on the deployment side. So just a quick outlook to what we are currently working on as well. Final words on AI and maybe the future of AI in our field. One of my favorite quotes here from the Terminator 2. But the major point that I want to make is that we are faced with exponential forces, technology improvements, and mostly not driven in our field, driven by the Googles, the Facebooks in the world, open sourcing their stuff, providing TPU data centers, which provide access even, once again, to the retail trader, to the interested retail trader in the near future, having data crunching capabilities never seen before. But the big ones, and a couple of examples, like 2 Sigma as a hedge fund, data-driven hedge fund, I can say, they have doubled their capital over the last 3 years from $20 to $40 billion. They accumulate talent like nothing, because once you have the capital under management, you get it. So this is what we see in the field, and more cash and investment flows into the area. And the last 2 slides are just related to what you might have heard of about the Go playing story. So here, one of my favorite books on the field, Superintelligence by Nick Bostrom, is from 2014, and he's one of the best known researchers in the field from Oxford, professor for the future of humanity there. And he wrote in 2014 that Go playing programs have been improving at the rate of about 1 DAM per year in recent years. If this rate of improvement continues, they might beat the human world champion in about a decade. So this is, again, one of the experts in the field. 2014, this was his forecast. 2015, for the first time, a Go Pro was beaten by AlphaGo. 2016, Lee as the world champion, I think back then, 14 times world champion, the best player ever on earth in Go, was beaten by the machine. So even experts in the field, they are wrong with regard to the predictions by 80%. And how fast we evolve is shown on the right-hand side. AlphaZero last year, they published, or the second half of last year, they published kind of the results of AlphaZero, which was not trained based on human games or whatnot. The first version was trained on 100,000 human games. But here, it simply by self-reinforcement learning, by playing against itself, after 3 days of self-playing, it was better than the version that has beaten the world champion back in 2016. And it was better by a margin of 100 to 0. And what they came up with is also with a chess engine, self-reinforcement learning. who has beaten the chess engine, which was the best up until that date, by 100 to 1. And you see at the same time, the hardware, the power consumption, has decreased considerably. They started out with 176 GPUs and they ended up with 4 TPUs, and you see the power consumption, which is kind of the best benchmark there, coming down by orders of magnitude. This is how fast we evolve. 1 year after 1 year we see such improvements here, and I'm pretty sure that this will significantly and forever change the finance field and algo trading as we know it. Thank you. I think we have time maybe for 2 quick questions. Afterwards I'm around as well, since I'm already a little bit over time.
Is it only for FXM, your library, Python library?
What I've shown today, this is about the FXCM Python wrapper indeed. So this is a dedicated library which wraps the REST API from FXCM, which is publicly available as of today. And of course this is specific to FXCM. There are similar wrappers for others available, and we have written also a bunch of things that are available via our, even the intro level courses. You get access to other wrappers and other stuff that we have developed in this field. One more? Yeah.
What is the impact of latency on your algorithm?
Latency is very important if we talk about high frequency trading. With regard to what I've shown and what I think will be more AI driven than high frequency, it is of course important, but not as important as with high frequency. For example, FXCM provides co-hosting, co-location capabilities in the data centers, as you know it from the big ones. So with FXCM you have one of the brokers in the market that offer a co-location if latency is something that is of importance to you. But again, if you trade for like examples that I've shown, if you're trading on 5-minute bars, then the last millisecond might not be that important. Of course, with regard to the machine, for example, we measure already the latency of order placement, the slippage and everything is measured there. Because in the end, you don't know. I might be sitting here and say latency is not an issue. In the end, it's a huge issue. So, I'm pretty sure there's not a huge issue with regard to what I've shown today, but if you change the rules of the game and trading other stuff, then it might become an issue. I think this is fair to put it that way. Yeah? Last one.
Why do you say that AI would be less important in higher frequency trading than in other parts?
Yeah, because what is happening in high frequency trading has not that much to do with regard to like the pattern recognition and going backwards in time, what I've shown. So. The approach and the ideas are, I wouldn't say they're not more simple, that's not the right thing, they're different. So here what we try to do is we try to learn something from the history, and most of the HFT algorithms, or take other algorithms like optimal execution. I mean, there are so many fields of algorithmic trading. It's not the AI-based long-short strategies or what there's a bunch of things. Like optimal execution with regard to liquidity, they are completely different algorithms. They have a completely different rationale behind them than what machine learning can help you with. A deterministic algorithm, if it works well, it's the one that I will take for that as well. If there is some rule that is, you don't need to train or like learn or whatnot, this might be the best thing to come up with in these fields. All right, I will be around afterwards to discuss for questions, and looking forward to the next talk.